Alright, we're going to have to be pretty careful with number 3. We're going to have to read it carefully and be careful with how we set up the equations here. We have an intake valve, so that's going to be positive. We have two drains, so those are going to both be working against the intake valve, so we're going to call those negative. And we know a couple different things here. We're also going to continue to use this sort of formula of one job equals the rate that it's done at times the time that it takes to do it. That's going to give you the rate, or the job. The full job is going to be done at that point in time. So we're going to keep coming back to that equation over and over again. The first thing we're told is that if the intake valve is open, the drain and the drains are both closed, so the intake valve is the only thing working, then it takes half an hour or 30 minutes, but we're going to call that half an hour. We're going to use hours to be consistent throughout this problem, so we're going to call that half an hour. So for the first equation here, what we have is we have job equals rate times time. So we can do one job, we can fill the whole tank at the rate, the intake valve rate, times the time that it takes to do it, which is a half. Well, I can just multiply both sides by 2, so the intake rate is going to be, actually I'm going to call that R, the rate of the intake. The rate of the intake is going to be 2. So we're going to hold on to that. We're going to come back to that in a little bit. We also know that drain number 1 drains the tank twice as fast as drain number 2. So we're going to think again about job equals rate times time. Drain number 1 can do one job at the rate of drain 1 times the time that it takes to do the time that it takes for drain 1. So we're going to call this R sub D1 and then T sub 1. So if I solve this for the rate, then the rate of drain 1 equals 1 over T sub 1. That's what this says. Just hang on to that as well for just a minute. Just hang with me. The third thing that we know is that drain 2, so that was just drain 1. We just treated it sort of as a, just very symbolically. We don't have any numbers really to go with that. But we do know that there's a relationship between drain 1 and drain 2. Drain number 1 drains the tank twice as fast as drain number 2. That means that drain number 2 takes twice as long. That means that the time for drain number 2 is going to be twice what it was for drain number 1. So the time for drain 2 is going to equal twice the amount of time that it takes for drain 1. So if I set up my job equals rate times time again, and now I'm talking about, this was for drain 1, this is going to be for drain 2, then drain 2 can do one job in the rate that it takes drain 2 to work times the amount of time, which is 2 times what T1 is. So this is going to be basically T2, but this is going to be, it takes 2 times what it takes drain 1 to do. And now I can divide by 2 T1. So the rate that drain 2 works at, we're going to call 1 over 2 T sub 1. So we now have these three things, and we're going to combine them all, because if all of the valves are open, then it takes 2 hours to fill the tank. So we're going to go back to this job equals rate times time. We can fill the whole tank, one job is being done. The rate is going to be all three of these that we just found. But remember, this one is the intake, that one's positive, and these two are negative. So basically the rate is the rate of the intake minus the rate of drain 1 minus the rate of drain 2 times the time, and it told us that if they're all three working, it takes 2 hours. So we can do one job, and it takes 2 hours. But now I'm going to substitute in. Instead of R sub I, I'm going to put 2. The rate of the intake is 2. The rate of drain 1 is 1 over T sub 1, and the rate of drain 2 is 1 over 2 T sub 1. So now I'm going to distribute. So 1 equals 4. Remember that this is 2 over 1, so I'm going to multiply straight across. So this is going to be 2 over T1 minus 2 over 2T1. So subtract 4. Minus 3 equals, combine these. Well, let's simplify this first. So now these are common denominators. We'll multiply by t sub 1, and we'll divide by negative 3. So t sub 1 equals 1. So the time for drain 1 time, is 1 hour. There was a relationship that we found between the time for drain 1 and the time for drain 2, and that was right here. So if we want to find T2, it's just going to equal 2 times T1. So the time for drain 2 is going to be 2 times the time for drain 1, which is just going to be 2 hours. So drain 2 takes 2 hours.